Hello learners, in this video let us continue our discussion on flip-flop. So in the previous video on flip-flop we learned what is flip-flop and what is SR flip-flop and its characteristics table. So we learned that in SR flip-flop when S equal to 1, R equal to 0, Q is 1, flip-flop is set. When S equal to 0, R equal to 1, Q is 0, flip-flop is reset. When both S and R 0, flip-flop goes to the holding state. And when both S and R 1, flip-flop output is undetermined. Okay, so it is not the valid condition. So there is a problem in the SR flip-flop that when both S and R becoming 1 is a invalid condition. How can we solve this problem? So this can be solved by now this is the circuit realized using the two NOR gate connected in back to back to realize the SR latch, SR circuit. Okay, SR characteristics table, SR latch. Now here that invalid condition problem is solved by connecting the S and R through the NOT gate, right? Now we have only one input and Q output. So in this, when you connect like this, S and R cannot be equal to 1. So the valid condition is invalid condition can never occur. Okay, that problem is solved. But one more disadvantage is this circuit will not go to the holding state at all, right? So when S equal to S and R both becomes 0, Q maintains the previous value. That is not done here because S and R cannot become 0. That is the disadvantage. So to solve that disadvantage, to rectify the problem, circuit is modified. So this is in this circuit, three states are this circuit follows the three states, right? That is S equal to when S1 R0 set state, S0 R1 reset state, and when S and R becomes 0 holding state. These three is become followed by this circuit. And one more advantage is in this circuit invalid condition never occurs. That is output will when S and R will not become 1 at any time. That is the advantage of this circuit. This circuit is called D flip-flop, right? D flip-flop. Always flip-flop have two input. One is the always flip-flop have the one important input called clock input. Here the enable is the clock input and D is the data input. Okay, so this is called D flip-flop. Okay, output Q follows the D, right? It can also be called as delay flip-flop. Now we know the limitation of this circuit. Actually the limitation of this circuit is the disadvantage of this circuit is when enable is 1 only, Q follows the D. When enable is 0, Q maintains the previous value, right? So when enable is 1, Q follows D. That is when D1, Q1, D0, Q0, Q follows D. But if when enable is 0, Q maintains the previous value. But this is not very much useful circuit when you use in an application, right? When you use in an application, this is not a very useful circuit because see the behavior of the circuit. When enable is high, here the enable line high is shown in as a red color line. When enable is high, Q follows the D. So whatever is there in D, that is available in the Q waveform. But when enable is low, that is shown in the blue color line, Q maintains the previous value. So here just look at just before the blue color line. So it was Q was 1. So when enable is 0, that is in the blue color line, follow the blue color line. During the blue color line, Q maintains the 1 high, previous value high, it maintains high until enable becomes high, right? Again when enable becomes high, Q follows the D. So look at this waveform. So in the waveform enable 1 இருக்கும்போது Q வந்து Dயில் இருக்கிறது அப்படியே ஃபாலோ பண்ணுது. எனேபிள் 0 இருக்கும்போது Q முன்னாடி இருந்தது அப்படியே மெயின்டைன் பண்ணுது. ஸோ திஸ் இஸ் த பிஹேவியர் ஆஃப் this circuit, right? But our desired requirement is when enable is high, Q should not follow D. That is, all the time of during the enable high, Q should not follow D. Rather, we need a circuit to the output should change, the Q should change only at the some instant of time, right? Only at the instant of time. That is kind of circuit only we require. That is called edge triggered D flip-flop, right? Edge triggered D flip-flop. So this is the very good circuit compared to the level triggered D flip-flop, right? So level triggered D flip-flop, the Q output changes whenever the level is high. But we need a circuit. We don't want the circuit whose output changes when the level is high. Rather, we need a circuit whose output Q should change only at one instant of time. That is, when the level changes from negative to positive or from positive to negative. So that is called edge triggered circuit or edge triggered D flip-flop. Now let us see in detail about the edge triggered D flip-flop in this video. So edge triggered D flip-flop, it's also called as master slave D flip-flop, right? Both are same. So edge triggered flip-flop can be constructed using the two level triggered flip-flop. Okay, so earlier what we discussed is the level triggered D flip-flop. Using two such circuits, using two level triggered D flip-flop, we can construct edge triggered D flip-flop. So the level triggered means it may be a positive level triggered or negative level triggered flip-flop. Let us choose positive level triggered flip-flop. So the previous circuit what we discussed is the positive level triggered circuit. Using two such circuit, we can construct the edge triggered D flip-flop. Let us see what is meant by edge. Edge means it is nothing but the transition from the negative level to the positive level, right? Or from positive level to the negative level. So from the transition from negative level to the positive level is called positive edge or rising edge. The transition from positive level to the negative level is called negative edge or falling edge or trailing edge. Now let us construct the positive edge triggered D flip-flop using positive level triggered flip-flops. Okay, so what is the idea? The idea is we need two positive level triggered flip-flop to construct the one positive edge triggered flip-flop. The idea is, look at the edge, positive edge here. In the positive edge, you look at the positive edge here. After the negative level, after the transition, you get the positive level. Okay, so negative level, transition from the negative level to the positive level, then positive level. This is how it changes, right? So the idea is we are going to use the two flip-flops, two positive level triggered flip-flop, and we are going to trigger the first flip-flop for the negative level and the second flip-flop for the positive level, right? And the output of the second flip-flop is the actual output. So actually the negative level to the positive level transition, the out is called positive edge. That means the circuit will respond only to the positive edge. Now let us discuss the circuit in detail, how to construct. Let us construct the positive edge triggered D flip-flop by connecting two positive level triggered D flip-flops in cascaded manner like this. Right? Look at this figure, you will get the idea. So here there are two blocks of D flip-flops shown here, right? Flip-flop 1 and flip-flop 2. Let the input of the flip-flop 1 is D1, output is Q1, and input of the flip-flop 2 is D2 and output is Q2. Right? Now how to connect these two flip-flop? Simply a cascading connection. That is, output of the flip-flop 1, that is Q1, is connected to the input of the flip-flop 2, that is D2. What about the clock? The clock input is here for the first flip-flop, that is for the flip-flop 1, the clock is inverted. That is, clock is given to the clock input through the NOT gate. For the second flip-flop, the clock is directly given, right? So when you connect in this fashion your clock, then it is called positive edge triggered D flip-flop. You will get the positive edge triggered type D flip-flop circuit. Okay. So here the flip-flop 1 will respond to the only negative level, because see, the flip-flop 1 and flip-flop 2 both are positive level triggered flip-flop. That means that will respond only to the positive level. But here before the clock input of the flip-flop 1, we have a NOT gate. So whenever in the clock input negative level comes, output of the NOT gate is positive level, then flip-flop will respond. Whenever the input positive level comes, output of the NOT gate is negative level. Hence, this flip-flop 1 will not respond to the clock in positive level of the clock input. Okay, it will respond only to the negative level of the clock input. But the flip-flop 2 will respond directly to the positive level of the clock input. That is the idea. So we call the flip-flop 1 as a master flip-flop and flip-flop 2 as a slave flip-flop. See, how does it work? Master flip-flop latches the D input in the Q1, and slave flip-flop transfers this Q1 to the output. That is what the idea. So during the one clock cycle, master flip-flop responds to the negative level, and slave flip-flop responds to the positive level. Right? So look at the diagram here, you can very clearly understand this circuit. So here the clock pulse, clock 1 is the pulse given to the master flip-flop. Okay, and clock 2 given to the slave flip-flop. Look at these two clock pulses, they are opposite. That is, when clock 1 is on, clock 2 is off. When clock 1 is off, clock 2 is on. Okay, because clock 1 is directly given to clock 1 is given through the NOT gate. Clock 2 is the actual clock signal. And let the D input is like this. Okay, D input 0 1 0 1 0 1 0 1. We are giving at the D input zeros and 1 alternatively. What about Q1? See, before that you have to very clearly understand. During the let us consider the first half cycle of the clock. So that is, in the first half cycle of the clock, clock 1 is on, clock 2 is off. Right? So clock 1 is on, clock 2 is off. So during this time, master flip-flop is on, slave flip-flop is off. Why? Because during the first half cycle, clock 1 is on, clock 2 is off. So clock 1 is on. So flip-flop is level triggered positive level triggered flip-flop. Hence, only flip-flop 1 will respond, because the clock 1 on time, but clock 2 is off. So flip-flop 1 is flip-flop 1 is on and flip-flop 2 is off. That is, master is on, slave is off during this positive off cycle. Okay. So master flip-flop is on when the clock 1 is on. At the same time, clock 2 is off. Then slave flip-flop is off. So during the first half cycle, master on, slave off. So we know the master flip-flop transfers the D input to the Q1 output. Okay, during this time. Okay, now say for a look at here, D changes from 0, 1, 0, 1. The same changes we are seeing at the Q1 output 1, 0, 1. Because master flip-flop is on, it transfers the T input to the Q1 output. At the same time, what about Q2? Slave flip-flop is off. Then Q2 does not respond. Q2 retains the previous value. The previous value is 0. Hence Q2 is 0. It remains in 0. During the next half cycle, okay, slave is on. Why? Because now Q1 is clock 1 off, clock 2 on. Clock 2 on, then slave on. Clock 2 on, then slave on. Master off. Now, this slave flip-flop transfers the D2 to the Q2. So, whatever is available in D2 will be transferred to the Q2. But master will not respond. Only slave will respond. Slave transfers the D2 to the Q2. Now, you see, master flip-flop does not respond. Then Q1 remains in the previous state. Previously, Q1 was high. Okay, when slave is on, here Q1 is high. Q1 is high. Then it maintains at the high. But in Q2, there is a change. Earlier Q2 was 0. Now Q2 follows the D value. So now look at D is 1. When slave is on, D is 1. Hence Q2 is high. Q2 becomes 1. Okay. And now see what happens. Next, during the next half cycle, again master on, slave off. Master on, slave off. So now what will happen? Master transfers the D input to the Q output. Now D input is changes 1, 0, 1. So, but what is the Q1? Q1 transfers exactly here. It is not shown. Q1 will be D input 1, 0, 1. But what about Q2? Our interested output is Q2. Q2 is off. Slave is off. So it maintains the previous output. So Q2 previously high, it maintains high. So again, when during the next half cycle, master off, slave on. So the positive edge come here. So the output will be a change. Q2 will change from high to low because now D is 0, so Q2 is 0. So when you look at this diagram, we understand that when master off and slave on, only the circuit responds. That is nothing but positive edge. Okay, master off, slave on. During that time only, the slave off, slave on, that is positive edge. During this time only the Q2 changes its output. Hence it is the edge triggered flip-flop. Okay, so here what we have done is, by constructing we have selected two positive level triggered D flip-flop connected in a cascaded manner at a time, and the clock pulse is given. Master and slave receives the inverted clock pulse. When master is on, slave off, master off, slave on. Okay, hence only during the transition the output Q changes. That is from 0 to 1. Only when the input clock changes from 0 to 1, only the Q output changes. That is nothing but the circuit responds only to the positive edge. Positive edge. That is why it is called as a positive edge triggered flip-flop. What about negative edge triggered flip-flop? How to construct? Same circuit. The only difference is now slave input is inverted rather than master input. That is, slave clock input is inverted than master input. See here, master clock input receives the output from NOT gate. Here, slave clock input receives the NOT gate output, whereas direct clock is given to the master. Now in this circuit performs in a work in this opposite way. That is, it will respond only to the negative edge of the clock signal. Whenever the negative edge means high to low transition. Whenever the high to low transition occurs at the clock input, Q changes. Q follows the T. Okay, that is the idea. That means master latches the D input into the Q1 and slave transfers this Q1 to the Q. That is the idea. It requires one cycle. Okay, right. So now look at the circuit diagram. It is only the block diagram. So we know replace the block by the circuit diagram of the D flip-flop. So this is the D flip-flop master. I mean this is the D flip-flop circuit, or D latch you can call. It will be good if you call it this a latch, because the difference between flip-flop and latch is whenever there is no clock, or the clock is there but the output to Q will respond only to the level of the clock, then it is called latch. Whenever the Q output responds only to the edge of the clock, it is called flip-flop. Okay, so actually we have to call this circuit as a flip-flop because this circuit only responds to the edge. And now let us try to identify whether it is a positive edge or negative edge triggered. It is a negative edge triggered D flip-flop because the slave receives the output of the NOT gate. That means slave receives the inverted clock signal. Okay, so here this 2-level triggered D flip-flop connected in cascaded manner. But look at here, I have mentioned it as a SR latch. It's good. Both SR latch and D latch is similar because almost the D latch is constructed using only SR latch. Between S and R input, if you connect NOT gate, it is D latch. If you are not connecting it, it is SR latch, right? So that is what I have done here. So this is nothing but a negative edge triggered D flip-flop. Okay. Now almost we have discussed all the. So we have discussed up to the edge triggered D type of flip-flop. Okay, positive edge triggered and negative edge triggered D flip-flop. Now let us see what is JK flip-flop. The another useful circuit constructed using the gates, using this back-to-back connection of the 2-input NOR gate is a JK flip-flop. So what is this JK flip-flop? See here also the core of this circuit, that is the heart of this circuit, is nothing but the SR latch. That is two input NOR gate connected in back-to-back. This is the core of this circuit. And we have an AND gate to give the clock input, right? But here we have a 3-input AND gate. One input of the two AND gates are tied together and it's a clock signal. The other inputs from each AND gate is for data input. One is called J input, another one is called K input. The other one input, see, look at the diagram. That input is connected to the Q and Q bar. Okay. So the upper AND gate, the input of the upper AND gate is connected to the Q bar, and in this diagram, and the one input of the lower AND gate is connected to the Q, right? So when you connect like this, now the circuit behavior is modified. What is modified? See, we know the SR latch have 4 different states. When s equal to 1, r equal to 0, set state. When s equal to 0, r equal to 1, reset state. When both s and r 0, holding state. Okay, but only problem with SR latch is when both s and r equal to 1. That is the problem. So we eliminated that particular state in a D latch or D flip-flop. But here this circuit will respond both when s equal to 1 and also r equal to 1 also, but in a useful manner. In this circuit, when s equal to 1 and r equal to 1, Q toggles. That is, Q toggles from the previous value. When previous value is 0, it becomes 1. When previous value is 1, it becomes 0. So the new state called toggle state is introduced by this circuit. It is called, that is the useful new state introduced in this circuit. It is called JK flip-flop. So J input is similar to the set input. Yes. K input is similar to the reset input, or look at the characteristics table. Okay. When clock is 0, output, when clock is 0, the Q maintains the previous value. That means circuit goes to the holding state, as usual in the D latch. When clock is 0, D latch also goes to the holding state. Here also the same thing. But when clock is 1, positive level, 1 means positive high, positive level, the Q responds to the J and K input. When J is 1, K is 0, Q is 1, so the flip-flop is in set state. When J 1, K 0, Q is 1, Q bar 0, flip-flop is in a set state. When C is 0 and K is 1, Q 0. That means flip-flop goes to the reset state. And when both J and K 0, flip-flop goes to the holding state, as usual in a D flip-flop. These three states are new, not new. It is also available in the D latch. But the speciality of this particular flip-flop is when both J and K becomes 1, Q becomes Q previous bar. Okay, Q becomes Q previous bar. That is toggling. When the previous value is 0, Q is now new value is 1, and the previous value is 1, new value is 0. This is called toggling. So the toggle property is the peculiar property of the JK flip-flop. Now it is good. So all the 4 states in this circuit is useful states, not like SR latch. Okay, so in SR latch only 3 useful states were there. In D latch also only 3 states: set state, reset state, and holding states there. But here we have 4 useful states for all the 4 input combinations J and K. So that is the advantage of this flip-flop circuit. Now when you connect the NOT gate between J and K, this will behave like a SR flip-flop, same, right? So behave like a D flip-flop. Even when you connect the NOT gate between S and R input, it behaves like a D flip-flop. Here also it behaves like a D flip-flop because we get 2 useful output, set state and reset state. So when you connect the NOT gate between J and K, it is called D flip-flop. This circuit is similar. The behavior of this circuit is similar to the SR flip-flop, in where between S and R NOT gate is connected. Okay, so SR flip-flop la S க்கும் R க்கு இடையில ஒரு NOT gate கனெக்ட் பண்ணி ஒரே இன்புட் எடுத்தாலும், JK flip-flop la J க்கும் K க்கு இடையில ஒரு NOT gate கனெக்ட் பண்ணி ஒரே இன்புட் எடுத்துட்டாலும், both can be called as a D latch. Both behave in a same manner. Okay, so that is when D is 1, when D is 0, Q is 0. When D is 1, Q is 1. Q follows the D. Okay, so that is, now this is the JK flip-flop circuit. Here in between J and K, when you connect the NOT gate and taken as a 1 input, it is called the D flip-flop. That is what here JK flip-flop converted into a D flip-flop. Okay, this is again useful circuit. And a very important circuit, the new flip-flop called T flip-flop. T for toggle flip-flop can be constructed using the JK flip-flop. That is the peculiar property of the JK flip-flop, toggle, by directly connecting J and K. Okay, when J and K input is tied together and taken as the single input, it is called T input. So this circuit will goes to the two useful state. When T is 0, both J and K is 0, Q maintains the previous value, right? That is holding state. When T is 1, that is J is 1 and K is 1, Q becomes the Q bar of previous value. That is toggling. Previous value is 0, now the Q will be 1. If the previous value of Q is 1, now the Q will be 0 when T is 1. Okay, so this circuit will toggle the Q output whenever T is 1, and whenever T is 0, it will maintain the previous value of the Q. So these two useful output, because of this useful output, this circuit can be used very much useful to construct the counter circuit. And that's all. Almost we have discussed the flip-flops, almost all the 4 different type of flip-flops. SR flip-flop, SR latch, D latch, SR flip-flop, D flip-flop, JK flip-flop, T flip-flop, almost all. But we have used to construct, we have used the NOT gate, NOR gate, we have used the NOR gate as a core circuit in all these 4 types of flip-flops. But the same thing can be constructed using NAND gate also. When you put a NAND gate in back to back, when you connect the NAND gate in back to back, the output of the upper NAND gate connected to the input of the lower NAND gate, and output of the lower NAND gate connected to the input of the upper NAND gate, this also behave like a latch, similar to the NOR gate, but with little difference, right? So with little difference, you can get the SR latch, right? That's all. Thank you.